So we're going to start talking about distribution, which is pretty straightforward. It's just the moving of our food from one place to another. We discussed this, or you answered a question about this a little bit in the midterm when we were talking about the buying from a local farmer versus buying from a faraway organic farm. Now, we don't have a lot of farmers in this country. Might not seem that way if you're a farmer's market shopper, or if you do a lot of gardening yourself, or if you are involved with local food movements. But the truth is, there are very few farmers in this country. And that means that kind of the consolidation of farms, animal production facilities, meat packing plants, food processing operations, warehouses, distribution centers, this often places further distance between where something's produced and consumers. And so consolidation in our food system is also concentrating those management decisions into fewer hands. So it's raising questions of growing market control by a few corporations. So, for example, over 80% of the beef packing market is controlled by only 4 firms: Tyson, Cargill, Swift, and Farmland. When Reagan was president, which was not that long ago, there was much more diversity. 36% of the market was controlled by those firms. So it's risen dramatically in, let's say 30 years or so. 4 firms control 80% of soybean processing. ADM, or Archer Daniels Midland, is the largest. The top 5 food retailers sell 42% of America's food. In '97, it was only 27%. So those retailers are Super Value, which is Albertsons, Lucky, Kroger, Walmart, Costco, and Safeway. So the average item in the supermarket is going to travel 1,500 miles before it reaches the shelf. So that's the average. Obviously, some things are more, some things are less. And we've talked about reasons why that might be good or bad. I mean, there's not many good reasons for things to be traveling, we think, but there have been some studies. So, like, you can find that the conventional food distribution system used about 4 to 17 times more fuel and emitted 5 to 17 times more CO2 than local or regional. This is a study done in Iowa. There was a Canadian study that estimated that replacing imported fuel with equivalent items grown in the local area would save transportation emissions equivalent to nearly 50,000 metric tons of CO2, or the equivalent of taking a little over 16,000 cars off the road. Food miles are a good measure of how far food has traveled. They may or may not be a good indicator of the food's environmental impact. So the impact depends really on how the food was transported, not just how far. So, for example, trains are about 10 times more efficient at moving freight ton for ton than trucks. So we could eat potatoes trucked in from 100 miles away, or potatoes shipped by rail from 1,000 miles, and the greenhouse gas emissions associated with each from farm to table would be roughly the same. So this is kind of hard to figure out. It's not necessarily easy answers. It's potentially confusing. And the ultimate impact is going to depend a little bit on how the food was grown. So there was a research study done in Sweden, actually, by Annika Karlsson Kanyama, and she found that it was better from a greenhouse gas perspective for Swedish people to buy Spanish tomatoes than Swedish tomatoes, because the Spanish tomatoes were grown in open fields while the local Swedish ones were grown in fossil fuel heated greenhouses. And that seems obvious, but there's subtler issues at play. Also, for example, Spain has plenty of warmth and sunshine that tomatoes crave, but its main agricultural region is fairly arid and is likely to become more drought prone in the future as a result of global climate change. So, what if water shortages require Spanish growers to install, say, energy intensive irrigation systems? And what if greenhouses in Northern Europe were heated with renewable energy, like some in Iceland are, that are heated with volcanic activity? So, maybe it's inevitable that we're gravitating towards an emphasis on food miles, because that's the last step before the food gets into our plate, and that's the part that's the most visible to us. And indeed, everything else being equal, it's better to purchase something locally than something far away if we're comparing exact systems. But a more comprehensive picture of all the trade-offs that require greenhouse gas emissions through all the phases of food's production, transport, consumption, life cycle analysis then reveals that food miles represent a relatively small slice of the greenhouse gas pie. Really, from the final delivery from producer or processor to the point of sale, that accounts for only about 4% of the U.S. Food system's greenhouse gas emissions. Most of them are in upstream miles. So by upstream miles, we're talking about all of the miles put on by transport of fertilizer, pesticides, animal feed. So overall, transport accounts for about 11% of our food system's emissions. By contrast, the agricultural production accounts for the bulk of our greenhouse gas emissions. About 83% of the emissions occur before the food even leaves the farm gate. So, proponents of localization, animal welfare, organic food, people will claim that the best way for concerned consumers to decrease the effects of their consumption would be to, say, buy local. And the results of the analysis shows that for the average American household, buying local could achieve at maximum about a 4 to 5% reduction in greenhouse gas emissions due to large sources of both CO2 and non-CO2 emissions in the production of food. Shifting less than 1 day per week, in other words, a seventh of your total calories, consumption of red meat or dairy to other protein sources, or a vegetable-based diet could have the same climate impact as buying all your household food from local providers. So, in other words, we've seen things like Meatless Mondays. Some restaurants are doing that as ways to promote certainly a healthier lifestyle, but possibly also greenhouse gas emissions. But let's recognize that's only focusing on climate-related aspects. Obviously, there are far other reasons to buy your food locally and to support your local food economy. Just let's be wary, though, about basing our rationale on emissions or greenhouse gases, because no matter how you measure it, on average, red meat is more greenhouse gas intensive than any other form of food. It's responsible for about 150% more emissions than chicken or fish. Second largest contributor to emissions is the dairy industry. So, plant-based diets certainly have some things to recommend it. What are some alternatives? Well, certainly shorter, less exploitative supply chains, localized food distribution channels, which we now have, a local food hub, and obviously direct relationships between consumers and producers. So, things like the farmer's market. It'd be interesting, though, to think about just a little bit about the fossil energy that we put into the system and what we get out. So our energy consumed is the fossil energy we put in is per year in quads. Now a quad is 8+ billion gallons of gasoline, a number I can't even really fathom. Um, for every unit of food energy produced, there are approximately 7.3 units of fossil energy for every unit of food that we get out. On-farm production is about 20% of that. 40% of agricultural production energy goes into making chemical fertilizer and pesticides. So we got the energy consumed, agriculture about 20%, transportation maybe about 14%, processing around 16, packaging materials somewhere between 6 and 7, food retail about 3 to 4%, commercial food service or restaurants, caterers, things like that, getting close to 7%. And then household storage and preparation, 32%. So by far the most fossil energy that we're using in our food is what we're using to store it and cook it at home. So should also think about that when we're thinking about our food miles or distribution. But sad to say that the fossil energy we put in is about 10.3 quads, which, like I said, is about over 8 billion gallons of gasoline. 10.3 quads. The food energy that we get out of that is only 1.4 quads. So we put a lot more energy into producing that food, getting it to ourselves, preparing it, cooking it, storing it at home, than the food energy that's actually available. So again, kind of a thorny issue. We don't necessarily have clear-cut answers about this. One thing is clear, though, in our system that is dependent on fossil fuel, that cannot last forever. We're going to have to figure out some alternatives, and it is likely that those alternatives involve some type of local control of the food system or localization, if you will, of our food. So that's it for this week.